Hello and welcome back to Chemistry Talk with Hunter. I'm Hunter, and today we are going to start my favorite subject in chemistry, stoichiometry conversions. So, the difference between molar conversions and stoichiometry conversions is that you require a reaction in order to perform stoichiometry equations or calculations of sorts. I like to think of stoichiometry and explain it to people as something like a recipe. If I need to make 20 ham and cheese sandwiches, right? I need 40 pieces of bread and however much ham and cheese, right? So it's a reaction. You need this much of this to get this. So in our case here of the reaction I've given you, you need 2 moles of C2H6 gas and 7 moles of O2 to produce 4 moles of CO2 and 6 moles of water. That's a combustion reaction. We'll do a separate video on types of reactions, but a combustion reaction is when you have a gas plus oxygen gas and get carbon dioxide and water as products. So now we will start our conversions, and we'll start off easy here. I'm going to change colors. Okay. How many moles of O2 are required to react with 24 moles of C2H6? Okay, well, I'm looking for moles of O2. So what is the easiest way for me to get to moles of O2? In this case, I'm going to use something called the mole ratio. And what that is like I said, the amount of products you need, or the amount of this with the amount of that to give you this. So in this case, you need 2 moles of C2H6 and 7 moles of O2 in order to react. So if you had 6 moles of O2 with 2 moles of C2H6, according to this reaction, they wouldn't react. You need at least 2 moles of C2H6 and at least 7 moles of O2 to react and to give you a product. So we need 84 moles of O2, according to this calculation, in order to react with 24 moles of C2H6. And that makes sense, because if you're looking at the molar ratio, you need more O2. You need 7 moles of O2 to react, but only 2 moles of C2H6 to react. So that answer makes sense. Your stoichiometry answer should always make logical sense, and this does. Okay. Now our question is, how many grams of C2H6 are required to react with 12 moles of O2? So it's flipped and an extra step. So let's start from the beginning. 12 moles of O2. I'm going to use my molar ratio that we just established. 2 mole C2H6, 7 mole O2. And now I'm going to use something called the gram formula mass. We've covered that in a separate video, but calculating molar mass. But I know that the molar mass of C2H6 is 30 grams. So that is our conversion, and we get 102.9 grams of C2H6. And that's our answer. So it's always also a good idea to cancel your units and make sure you're left with what you want, and that's grams. Okay, so that's a nice little problem, nothing too out of this world. Okay. Where'd that go? There we go, okay. How many grams of O2 are required to react with 200 grams of C2H6? So this is what we just did with an extra step, because we're going from grams to grams. So we have 200 grams of C2H6. Also, it's always a good idea to know where you're going in your conversion. Never, don't just guess your way kind of through it. Always make sure you have a concrete plan. So by demonstrating I have a concrete plan, I know this is going to take 4 steps. So I wrote out those 4 steps. That means I have a plan. I know where I'm going. So first I'm going to get rid of the grams here for C2H6 by using the molar mass. 1 mole has 30 grams. Then I'm going to use that handy little mole ratio we had to cancel out the moles of C2H6. And that should be 2, not 1. And now I'm just looking for grams of oxygen. So 1 mole of oxygen gas, 32 grams. Notice I put 32 grams and not 16 grams. It's a diatomic gas, so 16 times 2, 32 grams in a mole. And our answer here is a big number, 746.6 grams of O2. Once again here, you can look at this. Your answer makes sense. You need more oxygen gas to react than C2H6 gas to react in order to have a reaction. So here you have 200 grams of C2H6, but you have more grams of O2. That makes sense. Last question here. How many grams of CO2 are produced with 7.72 moles of C2H6? So, same thing here. I know this is going to take 3 steps, so I write that out. So I'm going to use the mole ratio here, except I'm going to use the ratio of C2H6 to CO2. So it's a 2 to 4 ratio per the equation. So 2 mole C2H6, 4 mole CO2. So it's just a different mole ratio. And I need to find grams of CO2. So I need to use the mass of 1 gram of 1 mole of CO2, and that's 44 grams. So my answer here is 679.4 grams of CO2. So this is basic stoichiometry conversions. In another video, we'll do molar volume conversions and limiting reactant and percent yield conversions. Hope this helps. Comment any questions and comment things you'd like me to do next.